Hello, welcome to the first video on combined stress from multiple loading types, meant to accompany the notes posted on Wednesday, April 6th. This first video will go through our problem statement, what it is, talk about what points we want to know the stress at. We'll go through determining the section attributes, such as the area, the second moment of inertia, the polar moment of inertia, things you should know how to do very easily by now. And we'll talk about what these stresses and moments are internally at the points that we're considering. We have this example problem to solve, where we have a circular rod and is subject to quite a few loads over here. And then we have 2 points where we want to know what the stresses are at them. This one is on the top and this one is on the side, point B. It's a 2-inch diameter bar, and this problem has everything. It has forces in the x direction. We'll call that the x direction. We'll call this the y direction. We'll call this the z direction. It's got torsion about the x direction, and of course this force in the y direction, this force in the z direction will cause moments about the x and y axis as well. And we've got this lever arm right there. So we've got a lot going on, and we want to know what the stress state is at points A and B. So the first thing, the very first thing we're going to do, I'm even just going to label as the first thing, is we're just going to have to get the section attributes. Alright, we're going to need to know about the cross-sectional area of this shape, about the second moment of inertia of this shape around all of its axes, and we're going to need to know the polar moment J. So we have, well, this is a 2-inch diameter. Let's just, I guess, draw that. Right there, let's specify it's 2-inch diameter, but also let's really clarify that right here is point A at the top, and right here is point B, and we have, well, X is coming right at you. This is the Y direction. If we've cut like that. And this is the Z direction. Okay. So we need the section attributes for this. Okay, well, area is probably the easiest, so let's start with that. It's a circle, so area is going to be pi times the radius squared. I said this was a 2-inch diameter circle, which is pretty convenient because that just means that we have pi square inches for our cross-sectional area. Then we're also going to need to look at our second moment for a circle. That's going to be pi fourths radius to the fourth. Again, very convenient that we have a radius of 1 inch. That's going to come back over and over in this problem. That's going to be 0.785, and that's going to be, of course, in inches to the fourth. Finally, we have the polar moment J. That's going to be pi over 2 radius to the fourth, and that's going to be, half of pi, which is 1.57 inches to the fourth. So now we have these cross-sectional attributes. We need to get into the actual loading that it experiences. So we need the forces and moments at A and B. So that's going to be step 2. So at obviously we're going to have 6 degrees of freedom and thus 6 moments and forces internally at this cross section. 1 for each direction, and then 1 for each rotation about each direction. So we'll have a force in the x direction. That will be this, 1,200 pounds. And then we'll have the force in the y direction, which we said was up. And if we ever have to check that, we've got that right there, shown on the cross section shown. And that's going to be this 600 pounds right there. And then we'll have the force in the z direction. And that's going to be this force right here. So we're going to have 400 pounds in the z direction. Now for the moment. I guess we usually call the moment about the x-axis torque. Sure, let's call it torque, but I'm still going to give it the subscript x because I want to be when you're doing a 3D problem, you're always going to want to have all of those, because if you just have one force F, you can really mess yourself up forgetting which way it's going. So we've got that is just given to us as a torque. It's 250 pound-inches. Now we have moment about the y-axis. Okay, that's the moment about this axis. That's going to be caused by this force right here in the z direction, because we have a lever arm from A and B over this cross-section up to this point in the x direction, and we were looking for a moment about the y-axis, so we had better have the force be in the z direction. And so that's going to be 6 inches times 400 pounds, which is going to be 2,400 pounds. So let's check to see which direction is it positive or a negative? Right-hand rule. Looks like that's going to be positive. Now, for the moment about the z-axis, and that's going to be caused by this force in the y direction. Again, we have a lever arm in the x direction, and so if we're going to get a moment about the z-axis, we had better have a force in the y direction. The lever arm is in the x direction is still 6 inches, but now we're multiplying it by this 600 pounds right here, which is going to give us 3,600 pound inches. Nope. That one should have inches too. So we've got Yeah. So that we've got this, let's check which direction is that going to be. Oh, looks like that's going to be negative. How about that? So we've got the section attributes for the section that this is going to act on, and we've got the forces and the moments that will be acting on those sections. So now all we have to do is determine the stresses from all these forces on these points A and B.